Welcome back, mathematicians. In this video, we are going to do more examples where we use the sum and difference formulas to find the exact value of my trigonometric functions. In this case, we're given that sine of theta is equal to -3/5, that the terminal side of angle theta lies in quadrant number 3, and we are being tasked with finding the exact value of cosine of theta plus pi over 6. My first goal is to rewrite cosine of theta plus pi over 6 using the sum formula for cosine. So this is equal to cosine of the first angle theta times cosine of the second angle pi over 6 minus sine of the first angle theta times sine of the second angle pi over 6. We now know, or we know the exact value for cosine of pi over 6 and sine of pi over 6, and we're told the exact value for sine of theta. What we don't know is the exact value for cosine of theta. Now, there are a number of ways to do this. You could use a Pythagorean identity. I'm going to go ahead and draw myself a picture to illustrate what I am given and what I need to find. So I know that this is a picture representing angle theta because I know that the terminal side lies in quadrant number 3. I'm going to draw myself a right triangle to represent the horizontal and vertical distance. And so what I know based on the fact that sine of theta is equal to -3/5 is that the opposite side, or the y-coordinate, will be -3. The hypotenuse or radius will be 5. And so I now need to find the x-coordinate, or the horizontal distance. Well, based on the Pythagorean theorem, I know that this would be a value of 4. And because I'm in quadrant number 3, I know it must be a -4. So now I know the exact value for cosine of theta, given that this is a picture representing the angle theta. So I'm going to go ahead now and replace these trigonometric functions with their exact values. So cosine of theta, based on the picture, is equal to -4/5. Cosine of pi over 6 we know is equal to square root of 3 over 2. Sine of theta, based on the picture or the directions, is equal to -3/5. And sine of pi over 6 is equal to 1/2. I'm now going to go ahead and simplify this expression, and what I know is that -4/5 times square root of 3 over 2, when I multiply and simplify, should be -2 times square root of 3 all over 5, plus, and I'm going to multiply 3/5 times 1/2 to get 3/10. Now, if you were being asked to rewrite this as a single fraction, you would multiply the first fraction by 2 over 2, so that way you could rewrite it as -4 times square root of 3 plus 3 all over 10. In our next example, we are being asked to find the exact value of sine of the inverse tangent of 4/3 plus inverse cosine of 5/13. What I'm going to do here is start with the inside of the sine function. So in other words, I'm starting with the inverse tangent of 4/3. So I am going to set inverse tangent of 4/3 equal to some angle, and I'm going to use alpha to represent that unknown angle. I'm now going to take the tangent of both sides. So what I have is 4/3 is equal to tangent of alpha. I'm going to draw myself a picture, and what I know based on the definition of inverse tangent is that my terminal side for angle alpha must lie in quadrant number 1 or quadrant number 4. Because 4/3 is a positive ratio, however, I know that it's going to be in quadrant number 1. So I have myself a right triangle here where I know the opposite side is 4, the adjacent side is 3, and then based on the fact that I can use the Pythagorean theorem, I know the hypotenuse or radius is a value of 5. And so this is a picture for angle alpha. I'm now going to repeat the same process for inverse cosine. So I have inverse cosine of 5/13 is equal to some angle. I can't call this alpha because I don't know if these two alphas, these two angles, are the same. So as a result, I'm going to call this angle beta. And so I'm going to take the cosine of both sides, and so what I get is 5/13 is equal to cosine of angle beta. I'm now going to go ahead and draw myself a picture, and based on the definition of inverse cosine, I know that my terminal side must be in quadrant number 1 or quadrant number 2. But because it's a positive ratio, that tells me I am in quadrant number 1. Now I have a right triangle. I know the adjacent side is 5. The hypotenuse is 13. Using the Pythagorean theorem, I can tell that the opposite side will be 12. I'm now going to go ahead and rewrite my trigonometric expression. So I have sine of inverse tangent of 4/3 plus inverse cosine of 5/13. I'm going to rewrite this using what I define the inverse trigonometric functions equal to as sine of alpha plus beta. I'm now going to rewrite this using the sum formula for sine, which tells me sine of alpha plus beta is equal to sine of alpha times cosine of beta plus cosine of alpha times sine of beta. I can now use the two pictures to find the exact value of cosine and sine of alpha and beta. So sine of alpha is equal to positive 4/5 times cosine of beta, which is equal to 4/13, plus cosine of alpha, which is equal to 3/5, times sine of beta, which is equal to 12/13. Now I'm going to find the product of each of these fractions, so I get 16 over 65 plus 36 over 65. Then finally finding the sum, I get 52 over 65. All right, guys, good luck.